Hey everyone, hope all is well. Just wanted to go over a calorimetry problem with you guys. Okay, so this is actually part C of your Gizmo. So I'm going to go over the example with you guys, which is number 1. So really all you have to do is follow the instructions on this, but I wanted to go over it with you guys because it is different than what we did yesterday. So if you look at the question, it says to solve. So when you mix two substances, the heat gained by one substance is equal to the heat lost by another substance. That makes sense. We talk about the conservation of energy a lot before we left. The law of conservation of everything basically says that nothing's lost. Okay, it's just transferred. So if energy is transferred to something, it's got to be coming from somewhere else. So for this example, we're supposing we place 125 grams of aluminum in a calorimeter with 1,000 grams of water. The water changes temperature by 2 degrees, and the aluminum changes temperature by negative 74.95 degrees. Make sure you keep that negative, okay? That's really important. So the first thing it asks you is, and answer these in order. Don't try to do part B before you do part A, because you have to kind of do A first because you can't do part B without it. That was a little redundant. So it says water has a known specific heat capacity of 4.184 joules per grams degrees Celsius. If you use 4.18, that's fine. Okay, 4.184 is just a little more specific. So it says use the specific heat equation to find out how much energy the water gained. So the first thing you need to do is, let me adjust this. Okay, calculate the specific heat. So we know the specific heat equation is Q equals mc delta T. Sorry for my handwriting. Okay, we know the mass of water is 1,000 grams. We know the C value of water, the specific heat, is 4.184. And we know the change in temperature, and be careful with this, read this carefully, the change in temperature of water is 2 degrees. So we know Q equals M, which is 1,000 grams, C, which is 4.184 joules per gram degrees Celsius, and the change in temperature is 2 degrees Celsius. So we're just going to multiply that across, and you should end up with an answer of 8,368 joules. Now, depending on the value you used for specific heat, if you used 4.18, for example, this value is going to be a little different. That's no big deal. If you got 8,360 versus 8,368, you're fine. Okay. Now, that's part A. Straightforward, just use the equation. Part B now. This is the new part. Okay. Part B says assume the heat energy gained by water is equal to the heat energy lost by aluminum. Use the specific heat equation to solve for the specific heat of aluminum. Okay? Because water gained 8,368 joules of energy, we can assume all of that energy came from the aluminum. So if water gains 8,368 joules of energy, aluminum loses 8,368 joules of energy. So the question's asking us to calculate the specific heat. So that equation is going to be C equals Q over mass times change in temperature. Okay? Now, let's see if we have all those values. The Q. We just said Q is going to be the opposite of the Q of water, right? So water gained 8,368 joules of energy. Aluminum is going to lose that. So the value is going to be negative. That's really important. So negative 8,368 joules of energy. Okay? Now, the mass of aluminum. Let's go back to our problem. Okay? Right here it says we place 125 grams of aluminum. So that's going to be our mass. Okay. It also says our change in temperature is negative 74.95. Okay. Now we just got to make sure we divide that by that times that. Okay, remember, if you're doing this in one step in your calculator, put these in parentheses. If you don't do 8,368 divided by parenthesis this times this, your order of operation is going to get messed up. Okay, but if you put these numbers into your calculator, you should get 0.893 joules per grams degrees Celsius. Okay, and that is your specific heat of aluminum. Okay, that's an awful square, I'm sorry. Okay, now if you look down here, it says aluminum's accepted specific heat value is 0.900 joules per grams degrees Celsius. Check your work. We're never going to get that exact number. If you did your experiment extremely well. Okay, that number is used to compare. If you have 0.893, you got 0.9, you're good. Okay, so if you get in the vicinity, you're good. The reason being is you're always going to lose some kind of heat or some kind of accuracy in your experiment. Now, looking at number 2, I'm not going to do this for you, but just explaining it, okay? You're going to use the Gizmo to get your change in temperature values. You're going to calculate the Q for water, and then you're going to use the negative Q for water to calculate the C value for copper. Okay, so basically the same thing we're doing here, it's still breaking it down in steps. When you get to the back page, it's asking you to do it in one step. Remember, it's still these 2 steps. All right, guys? Hope that helps. If you have any questions, let me know. Okay, I can absolutely go over this stuff with you. Good luck. Keep up the good work. Talk to you soon.